Okay, great. All right, so today we will be beginning on working with SAS Studio, which is an internet-based interactive environment where you can type your SAS codes and perform analysis on the internet. As long as you have internet access to this environment, you're able to perform SAS Studio. The only limitation is that there is a limit on the data set file that you can import if it is an external data set that you are using. There is a limit on the size of the file that you can import to SAS Studio, which is 1 GB. So as long as your external data set that you will be importing is less than 1 GB, you are able to use SAS Studio to perform analysis. So I've provided a website and I can share that, and I have shared that website in email. I can share that with you, with this PowerPoint with you after the course as well. So this website is where you register for your SAS Studio account. So it says sign in over here when you select on this website, and it will navigate you to register. So if you don't have a SAS profile already, you create a SAS profile and then you register into the SAS Studio account. So I'll just register.
Neha, we can't see your screen.
Sorry. Let me show my window. Do you see both screens next to each other now?
Yes.
Yes.
Okay, great. Oh, sorry for the technical issues. Okay, so this is the website, welcome.oda.sas.com. When you go to this website, it will navigate you here. On the right-hand side on the top, it's the sign-in option. Here, it will allow, if you already have a SAS profile, it will allow you to log into your SAS Studio account. If you don't, you create one by selecting don't have a SAS profile. So I will log in since I already have a SAS profile. And then this is how it navigates. It shows you SAS Studio. To access where you write your code and perform your analysis, run your data management steps, you select launch. So then it will navigate you to another page. Loading. And it opens you to a sheet open. So if currently right now I have a sheet that has already been open once since I last closed it, which is the introduction to data management using SAS Studio sheet. However, if you're a new member, you will see a blank sheet open on the SAS Studio account. So here we're going to navigate through looking at each navigation panes and then also work on some basic syntax for performing data cleaning measures and exploring your data. So in this course, we will be running a web-based browser. There's no download that's required, except for the fact that if you have an external data set, you of course have to download or keep your external data set and import it into the SAS Studio environment, which I will show you soon. And then it also provides you with information on your logs, your codes, whether you've received any errors. So that I will show you in a few minutes. Okay. All right, so let me give you a brief introduction for SAS Studio. Here, as we go through the process of understanding our data and making, an understanding of the framework of our data and performing data analysis, there are a few steps that we take, which is first, we need to have access to the data and be able to read the data into our SAS Studio. Then the next step would be to perform data management and data cleaning measures on the basis of our research question of interest, or, if how to explore your data, see if there are any missing values, handling your data in terms of the variables that you're interested in on the basis of your research question of interest. And then the third step would be to analyze your data. So if you have a research question, hypothesis, you will perform analysis on the data based off of your research question. The last step would be to export the results and make interpretations, perform data visualizations. For example, if you want to create any visual plots for your manuscript or your results, if you want to create a table for your results, that's the last step we perform in terms of obtaining your results and reporting results that you've obtained for your research analysis. So first, let's begin with exploring the SAS Studio environment, and I will make this larger now because we don't need the other slide. Can you see the larger portion of this whole SAS Studio environment now?
Yes.
Yeah, okay, great. Okay, so first I will show you how to work on already saved example in SAS. That will be an already saved example that already is uploaded in SAS, and you can use that to practice. But before that, let's begin to look at the SAS Studio environment. On your left-hand side is the navigation pane where you have servers, files, and folders. Here you have the option to create folders. So I have folders that I've created, for any project that I'm working on. I have created a folder for seminar series, which I'm using to, upload any external data set that I will be using, and also for saving my SAS code that I'm writing here on this section. So this is where you will save any, upload any Excel, CSV formatted files into your SAS Studio, and also save your SAS code for access later on. Then we have our tasks and utilities. This is great for anyone who doesn't have an idea on how to perform certain SAS codes. SAS has been very useful in providing certain data, prior data activities. So there is ways to characterize your data, describe missing data, list data, and also perform graphs, create graphs, and perform few analyses measures if you already don't know the syntax. So just hypothetically, for an example, let's say I will select characterize data. It opens me up to a new page. This here, since I haven't uploaded any data into SAS yet, SAS Help allows me to access data sets that are already readily available in SAS to use for practice. So let's say we select sashelp.cars. Cars is the data set that we're focused on, and we select a variable called type. And then we perform run with this run option with this person running. So once we select run, here in the code generates for characterizing your data. So since our variable type was a character variable, it ran a frequency distribution table for analysis. And then in the results section, you can see the frequencies for this categorical variable called type. And then it also gives you a plot, a bar plot for the distribution of type. So this is one helpful way if you don't know how to code and would like to perform some basic syntax in terms of, running means, obtaining descriptive statistics, or performing graphs, or even basic analysis. You can use the tasks and utilities section of SAS to perform any basic analysis. I will be showing you a code from right now on my own without using the tasks and utilities, but feel free in your own time to look through tasks and utilities and see what other options that they have in terms of your analysis plan. Snippets are, usually lines of commonly used codes or text that are already saved into SAS, and they're easier access to use. So they have, a one-way ANOVA snippet that already is saved into SAS, and whenever you select it, as long as you have a SAS code sheet open, it automatically inputs the saved syntax code into the sheet wherever you have your mouse selected. So I'm not going to run that right now, but just an idea of, if in case you don't know which code to work on and you know that you need to run a linear regression or a one-way ANOVA, you can use these snippets to already import the code into your code in SAS code environment. The third option is libraries. Libraries is very important because the SAS library is where the folder is located on the user's disk drive. So, or on this internet, so on this SAS Studio environment. So as long as you save your folder or your file, your data set that you've created into a specific library, you will be able to access that file later on, even after closing SAS Studio and logging back in by running a library code, syntax code, which I will show you in a few minutes. So pretty much the library allows users to safely store data sets and user-defined formats so they can be accessed without having to reload or reread them from an external file every time we begin. So as long as we have created a data set using a specific library and we rerun the library function once we reopen SAS Studio, we don't have to run through all the data management steps again. That data set has already been saved into that library that we've created. All right, and then file shortcuts, it enables you to quickly access files that you specify. So you can create file shortcuts on your server by creating, like, if you have any results that you want to create as a shortcut so that you can access later on, or if you want to create any table that you want to create as a file shortcut, this is where you can save the results, a table or a plot as a shortcut so that you are able to access that later on through a URL link. Okay, so let me close this characterized data option for now. So for this course, I will begin with showing you how to perform some data management queries in SAS using a data set already available in SAS. If you go on libraries, my libraries, these are all the libraries that are in your SAS folder. So one thing to remember is that if you're working on any data and you don't specify a library, it will automatically be saved into the work environment. So it'll be saved into your work library. However, once you close SAS Studio, the work environment is lost after that. So if you have run any data management, any data cleaning steps, or performed any changes on your data set and did not save that data set into a specific library, that was saved directly into a workspace. But once SAS Studio closes, once you log off of SAS Studio, all of that work will be lost in the sense of you will have to rerun the codes again to be able to obtain that result. So the only reason I use work is when I am performing a lot of data manipulations in current steps, and then I don't want to save each and every manipulation and each and every data step. So I want to save the end result. So for example, if I have worked on cleaning data sets and creating new variables in 4 different steps, but I don't want to save all the 4 different steps in 4 different data sets, I will just save the last file and into my library rather than saving for all 4 of them into my library. So I'll show you an example of that in the soon. The data set we will be using in this course is, and to be able to access, you can go on SAS Help. SAS Help has freely available data sets, so they have a lot of options that you can use to practice these with these data sets. So the data set that we will be using will be the heart data set here. If you go on SAS Help Library. So the heart data set, I can double click my heart data set here. On the left-hand side, you'll see the columns, the variables that are available on the left-hand side in this data set. And then on the right-hand side, you can see the entire data table in the grid. So here you can see that there are 5,209 rows and 17 tables that are already, 17 variables that are in your data set. So this is the data set that we will be using today to perform any basic analysis. Before I begin, I do want to kind of give you an idea of the basic SAS syntax rules. So there are a few syntax rules in SAS, which is semicolon. Every statement should end with a semicolon. When you're running a SAS statement and you're sure that this is a statement that needs to be transcribed and it needs to be implemented, you end that code with a semicolon. The quotations are used when you're working on a character variable or recognizing a text. So then you can use a quotation mark to recognize a character or a text variable, or apostrophe. So these are the options. So you can use the double quotes or a single quote. Another great thing about SAS is that it's flexible, so you don't have to, worry about the capitalization, or you don't have to worry about breaks in the middle of your SAS codes and indentations, because SAS only reads the specific syntax between your data or procedure statement and then the semicolon. So it doesn't, even if you have breaks in the middle, for example, here are the breaks, it won't read that. It doesn't process that, so it's okay. So as long as you have, it's very flexible with capitalization, indentations, and line breaks. It's not case sensitive, so you can have upper or lower case, it doesn't matter. As long as you write your variable names correctly, that's all that matters for SAS. Spacing and extra lines are ignored between the statements. And if you're running a code and performing a procedure, you can have multiple statements in one line, as long as each statement is segregated by a semicolon. So as long as they're separated by a semicolon, it will identify it as one syntax, and it can be written in one long line. It doesn't have to be indented in the next line. I like to indent my code so that I can differentiate and be able to navigate through what codes I've run, so it's easier to backtrack and realize and not miss a step. But of course, it depends on how you like to work and how you would like to space your statements out. Okay, so first and foremost, my first highly recommendation is that we begin with creating a library in SAS. So here we already have this library. We already have a few libraries that were created. However, I personally like to create a library that I can identify and save my files into that specific library. So libraries will allow us to store whatever data management and data cleaning steps or analysis that we're running into that specific library. So if the data you want to work with is already in the SAS data set stored somewhere, it's already in the SAS data set, then all you need to do is run a live name code with a library code to create a library. And if not, then you would have to import your data set. So first and foremost, since I want to create a library, I want to create my library in my seminar series folder. So if I go to my seminar series folder and I right click, I have the option to go to properties. When I go to properties, you find the pathway of where your properties folder is saved on this SAS Studio environment. So I would copy this location, and then to create a library, I will call it live name, the library name that I want to create, and then specify the path and end the statement with a semicolon. So here the live main is pretty much the statement which is used to assign a location to the library. So we created a library called mylib using the statement live name in our path or in our folder seminar series. So everything that we will be working on with the library mylib will be saved under the seminar series folder. Once a library, so let me run this code. When I run this code, I get an option here, the log. So this right-hand side, we can see we have 3 environments, which is the code environment, the log environment, and the results environment. The log environment is helpful because once we run a code, it lets us know whether our code was run correctly, whether we had any errors or warning signs. So this is very helpful because it tells us whether our syntax and our code was read correctly or incorrectly, and if we need to make any changes to our code in order to correct our syntax. And then the results right now, since library is not a specific table or a visualization step that we've created, there is nothing on the results section that's being shown. However, of course, in the near future, when I run on a few codes, you'll see that there will be results that you can visualize in this section. So according to our law, our library mylib has been successfully assigned, and it's been assigned to the seminar series folder. So once our library has been assigned to a location with our SAS data set, so now this data set can be referred to in statements using two parts. So here, another option here is to right click and upload files. So if you already have it, since we're using the already saved file in SAS, we don't need to upload any files. However, if you have an external data file that you would like to import into SAS and you want to use that external data file, you go on your folder, you right click, and you navigate to upload files. When you select upload files, it will allow you to choose files from your desktop. So when you select desktops, then it'll go and you can select your file and open it. So that's a way to upload your file. So for example, I had a CSV file called heart, which is similar to the SAS help file. I just exported it into a CSV format and saved it on my desktop and uploaded heart.csv file into my seminar series folder. So now my external data set called heart has been uploaded into my SAS Studio in my seminar series folder. To work on this heart data set, I will have to import it into the SAS Studio environment after uploading the data set. So once the upload has been done, I would have to import that data set. And that is the last step that I will show you. For right now, we're just using the SAS help heart library table. So before we begin, I want to just let you know, once you have assigned a library, when you want to save your data sets, you have two parts. Your data set, the first part would be your library name, and then the second part after the period will be the data set name. Every time you want to save the data set into your mylib library, you first write mylib, and then you put a period, and then you specify the data set name that you are including. So for example, if we have a data set named heart in our seminar series folder, which we've told SAS that our location is the location of our library is called mylib, then we will refer to this data set as mylib.heart. So we're referring to a data set called heart, which is located in our seminar series folder, and we've told SAS that it will be located in our mylib library. The next steps are to get an understanding of two main blocks of code. So this is a very basic format and basic importance of understanding SAS Studio and SAS coding. SAS consists of two main blocks of code, which is one, the data set, and two is the proc step. It's called proc, but it's usually referred to as procedure. However, we use it in SAS, you call it as proc step. So in the data step, you can perform any kinds of creation, you import the data, you can modify your data set, you can merge your data set. So any kinds of data changes that will be made using the data step. And if there are any specific procedures that you will be running. So for example, if you are running to obtain descriptive statistics like means or frequency distributions, or even running any analysis in SAS, you will be using the proc step, so which runs a specific procedure. And each of the data and proc step will end with a run statement followed by a semicolon. So as long as your data steps have a specific line, and then you mention the run statement with a semicolon, that means that you want this whole chunk to be read into SAS and to be run. So for example, I have been using SAS help.heart, which is the heart data that was freely provided to us through SAS. And I want to create a new data set in my library, mylib, and call it my heart. So this is my new data set name, and this is the library that I'm assigning this new data set name to. but I want to use my old, which is already readily available data set in the SAS help library, and create a new data set using this old data set. So I will use that step called data to create a new data set. So the data set step starts with data, and then the new data set that you've created with your library name, and then the set option, the set statement allows you to set it to the old data set that you were using. So the old data set, which is our freely provided HEART data set that we were using. And then we run this statement, we end the statement with the run and semicolon option. So one thing to note here is if you want to run a specific statement, I would highly recommend you select the statement and then go to the top and run here or press F3. Select the statement and then select the run option. When you select the run option here, your output data is created. And now it's you can see here, we created a mylib.myheart data set, which was in the mylib library. And it's the same data set that was in the SAS help library, but I just created a new, like a copy, a clone of it, and called it myheart in my mylib library. So it's the same data set, just a clone copy of it. And then in the output data, you can see the data grid, data table. However, sometimes I like to visualize to see how the data looks rather than just looking at it in the data grid format. So I perform a procedure called print. This print procedure, it pretty much tells the proc print procedure, it tells SAS to run the print statement where it will print out our myheart data set in a table format. So I will select this proc print statement and select run. It'll take a few minutes since it's a big file. I mean, like more variables and more rows. And then the results here. Okay, so now in the results, you see the table format. So this is how you can visualize your table in like ballpark view if you want to explore your data set. And you know, sometimes in the output data table, it's really hard to see each variable next to each other and see how the table exactly looks. This will be a great way for you to look and visualize how your data is formed. You can also specify certain variables that you want to see in the code, where you can specify specific variable names. So for example, let me go back on results and say that I only want to look at status, sex, and height. So I'll say variable status, sex, and height, and then I'll put a semicolon and then a run statement. And then I'll rerun this. Now here you see that it only showed me the variables that I specified in my results table, in my results tab. So it's a good way to you know, if you have a large data set and you have a large number of variables or columns in your data set, then you know, it's good to just specify the ones that you're interested in visualizing, and you can take a look at it, see which variables are of interest. And you know, whether there's any missing, like from ballpark view, I can see that there may be some missing values, or you know, what's the format of my variables so far. Another beneficial step is to look at, you know, how your variables, the variables are specified and their specifications and the number of observations, which can be performed using the contents statement. So contents allows us to view specific contents of our data set. So you run a procedure, a proc statement with contents, and then you type data equals to your specific data set. So I'm using mylib.myheart data set, and you can run this code to obtain content information. So this gives you an overall overview of your data set. It's the data set name. It'll tell you how many observations are in your data set. It will give you information about the variable names, the observations length, and then what's most important is the alphabetic list of variables and attributes. This is important if you know, you see that there's a specific variable which is saved in a different type, numeric or character format, and you would like to either convert it into a different type of format or change it, then this portion is available to see what is the type of your variables and whether you need to change that format or not for your analysis. And I will show you how that changes are done in the coming sections. Okay, so now that we have had an overview of our MyHeart data set from our contents, we've looked at it, we've looked at the data table from our proc print procedure. Now we can begin with some basic modification steps. So we want to modify our data set. And if we want to modify our current data set and change it to make it into either a new data set, we use the set statement. So for example, as I mentioned earlier, the set statement uses my old data set, which is however old versions that I'm using. And then I created a new data set using the data statement called myheart_new. And it's pretty much creating a clone or a copy of that data set. This is beneficial because sometimes we perform various multiple steps of data cleaning measures, or make many changes in our data sets, but we don't want to overrun a specific or make or oversave our changes on our old or on our existing variables. So for example, if we wanted to create new variables or recode any specific existing variable without like permanently changing our old data set, we just create a new data set using the set option. And then after the set option, you can specify certain lines of codes of the types of edits or changes that you would want to make. And, I'll show you a few edits and changes as an example here. So it's very helpful, if you don't want to rerun and overlap your changes in your data set, it's very helpful to just create a new one using the set option to your old one. And that way you can also backtrack your work easily and see, okay, well, my MyHeart new data set had this change, but my mylib.myheart data set was the older version and it didn't have that change yet. So what is the difference between these two? Okay, so in our data set, we have, some options for variables. So a few options for variables, like we can rename our variables. We can drop few variables from our current data set. So the two options that are usually in our data step, the two options that appear in the parentheses are right after either keep or drop. The keep option is usually included in the set step, where keep is pretty much telling SAS that I want to keep these specific variables. And the drop step is telling SAS that I want to drop these specific variables. So it's telling SAS to remove the variables that are listed from your data set, whereas the keep option is telling SAS to keep only the listed variables in your data set. It's not always required, but sometimes when we have a large number of variables in our data set and we don't want to keep all of them, this is the best way to only keep the variables of interest, and remove those that you don't want to keep. So you can also just perform one step, and rather than performing both of the steps, so either you drop the variables that you're not interested in, or you keep only the variables that are interested in. So if there is, out of my 50 variables, if I'm only interested in keeping 10, I would rather just type out the 10 keep option rather than typing out the 40 drop variables in my data step. So for example, the first example, let's say from my MyHeart data set, and let me just show you the MyLib.myHeart data set again. So let's perform proc print procedure. Data is equal to mylib.myheart and run this statement. Depending on the size of the file, it just takes time to load into the results. So here, your mylib.myheart data set had information about the status, death cause, age, CH diagnosis, sex, age at the start, height, weight, diastolic, systolic, MRW, smoking, all of these variable information. Let's say that I only want to keep my age at start and all the characters. So my age at start is a numeric variable, and I want to keep all the remainder other character variables. So any character variable such as status, sex, cholesterol status, BP status, I want to keep all of those variables. So I create a new data set called work.myheart2. I set it to my old data set called mylib.myheart, and then I only specify keep option after parentheses equals to the age at start variable, and then specify underscore char underscore. With this underscore char underscore specifies to keep all the character variables that are in this data set. And then I end the statements with a semicolon and a run option. When I run this code, here you'll get a new data table created, which is, since I didn't, and I want to mention something afterwards, but if you see here, all of the character variables were included in my data set, and the only numeric variable that I kept was age at start. So here I was able to, keep certain variables that I was only interested in, apart from keeping all of the variables from the previous data set. Now notice here in the table here, my data set was saved in work.myheart2. So because I didn't specify, or I specified work here instead of my lib, my data set was saved into my work library. So if you go on library on the bottom left-hand side, and then you press the My Libraries button and you select work, you'll see a data set called myheart2 created, and you can access that data set. So you can always select and look at how your myheart2 data set looks in your data grid. However, once you close SAS, this myheart2 data set will no longer be available in your work environment. So you'll have to rerun everything or rerun that code to be able to have it in myheart2. But if you go to mylib, you can see that my heart, example heart, these are certain data sets that I've already saved. And once I run the library name, the lib name statement, these data sets will be already saved into that. Now, moving forward, if you want to keep only the numeric variables, you can specify the underscore numeric option, and it will do the same thing. So instead of keeping the character variables, specify the numeric options. And then here you see I kept only a sex character variable, and I specified the numeric option, and it kept all the numeric variables that were in my data set. Also, if you want to drop specific variables from your data set, that statement is the dropping option is kept in the data statement. Why? Because the set statement is the first step that takes place. When you are creating a new data set using a previous old data set, when you select set statement, the procedures that you're telling SAS to run after the set statements, they are the first steps that take place. And then after that, the finishing touches will be whatever step was in your data statement, which is created my work.myheart2, and it dropped variables called sex, age at start. So I created a new myheart2 data set, and I dropped sex, age at start. So if I run this code and I just look through the columns here, you can see that sex and age at start are not included. So this is just an option of, like, if you want to get rid of certain variables that you're not interested in, or if you want to keep only few variables from your large data sets, these are a few options to use when you want to narrow down your data set and make it easier for you to read and run. Now, another option is to rename specific variables. So for example, I have variables that were already named in my data set. For example, if I go on, let me just open my heart data set here. And let's say that I want to rename my age at start data set, rename my age at start variable to BEG age, or rename the sex variable to gender. So for that option, you will create the syntax that you will be using will be rename option in the data step. So that option will be performed as a parentheses rename equals to the old variable equal to the new variable. So here I have two variables that I'm renaming, and notice that I don't have to put a comma in between. So as long as you have a space in between, SAS identifies the variable, the different variables, and it looks at the space as, you know, a comma, and you don't have to mention any specific comma in the SAS Studio environment. You just have to give it a space, so it looks at separate individual entities. The rename statement allows us to change our old variables into a new variable. So here we're renaming this age at start variable to beginning age, and sex from our old variable sex to gender. And then I set it to my old data set, and I created a new work.myheart2 data set, which is saved in my work library since I don't want to save it. I'm only saving it temporarily. And then of course, here you see BEG age was created. I don't know if I can show you here. Yeah. So sometimes what happens is, if you're looking at the grid, what happens is sometimes when you created a new variable or when you make changes, sometimes the columns, obviously the columns are listed here. However, they might not be seen on the first page, first grid. So you will have to go maybe towards the end to like find your grid, find your variable, and to be able to see your columns. So here you see we changed beginning age, age at birth to beginning age, and then sex to gender. That's one difference that we made. These are just few basic options to, you know, drop variables or rename your variables that can be helpful based off of, you know, whatever variable names you're given in your external data sets. Now, another important syntax is informats and formats. In SAS, we use informats and formats to interpret our data values. So basically, our informats tell SAS how to read the data, and our formats tells SAS how to print our data, how our data is shown on our results. An in-format option is usually when, you know, we have to, usually written, in-format options are usually written when we have to specify a type of character, a type of numeric format, or a type of date format. So there are three types of in-formats. Character, which the syntax for in-format is specified as with a $sign, and then, you know, you can either write the in-format name or a W dot, and it reads the character data of length, with length would be the W. The numeric option is you'll have the in-format variable and then the W dot D. So the W reads the numeric data in format of length W with a decimal point D if it's for numeric. So if you have like 10.8, you know, you'll mention a decimal format 1.1 instead of having like 0.5 or something. So it just gives the length of decimal points that you want for your numeric format. And then for the date format, I've given as an example here, this format tells us to read our date structure as months, dates, and years, and then the length of our date. So if whether that's in, you know, whether it's 10/20/2024 or whether that's 10/20/24, it specifies the length of our date here. So the period pretty much helps SAS recognize that there is an in-format option before it, in-format name before it, and it's not a variable. So every time we have an in-format and we're creating an in-format for a specific variable, we have to end it with a period, because that's how we will be able to tell whether that's an in-format. So let's begin to create like a sample data set. If you don't have any data set, if you know, you're not working on an imported data set, you're working on it, you're just creating your own data set, you can perform that by using the data step. So here we're creating a data set called sample data, and we want to create variables called name, sex, and birth date in that sample data. So we use the input statement, where input statement allows us to input the variables that we are enclosing in our sample data. So here we have name, and then I have a $sign because my name variable will be a character variable. and my sex variable will also be a character variable. If I had a numeric variable, I would not specify the $ after that variable. However, since these name and sex variables are character, I have to specify a $ so that once the data step is completed and we run this step, we can see that the name and the sex variables were considered as type character. And then for birth date in the input statement, I have to mention the format, the type of format that I want to assign this birth date. So I start in the input statement, you have to start the format option with the 2 dots, month, day, years, and then 8 period. So here I'm saying it's month, day, years, and then the length of my date variable will be 8 digits long. And then I have to create a format to this birth date variable so that when my SAS runs when my SAS runs this entire code, it runs it in this specific format, in this month, day, year, in 8 digits format. And then after I specified a format to our data variable, I have to mention data lines. Now, this data lines is important. You mention data lines and then end that data line statement with a semicolon, because after this, you can create your data set. So for example, here, I only created one row, which is Ryan, male, 10/12/95. His date of birth was 10/12/95. However, if I want to create multiple rows, every row has to be below each other. So let's say example, I created Anna sent 0402 2000. I mean, no, like 01. Okay. So, and then as many people that I want to add into this data set, I will do it every row below. So for this, I cannot put multiple values in a row. I have to, for the data, to create a sample data set, I will have to run every row in each individual row. It has to be segregated. And then I end this once I have uploaded all, or once I have written down all the variables that I want, all the rows that I want in my data set, I end it with a semicolon, and then I mention a run statement and end it. So when I run this now, we have created here. Yeah, we have created a data table called sample data with Ryan, male, and the birth date. So the birthday here, you see it's month, date, and then the year. If you want, you can also look at the contents of this by saying proc contents data is equal to work.sample data and run the statement. And you'll see here, you have one observation in your sample data. The birth date is in this format. My name is in character format because we specified the $, and the sex is in character format because we specified the $. So this is a good way to recheck whether your variable types have been correctly stated and the formats are correct. You can also change the format of any variable in your data step or proc step procedure. So if it's already a data set that you've been using and you want to change the format of it, you can always change it. So for example, right now, the format of our data set was MMDDYY8, which is creating birth date variable. And we wanted to change it to a word format. So instead of changing it into a word format, instead of keeping into the month, day, year option, we want to see it as words, right? So here I will, here I will run a proc print because this is the same step that I did here. It's just that I created a new data set and I set it to my old sample data set and I formatted birth date. But you don't have to run this because it's already created as month, day, year 8. This is only if I wanted to create a new data set and I wanted to work over that. So I run code. And then now proc print. When I'm printing it, I want to format my birth date and visualize it as a word date. So when I'm visualizing it, I write word date, and then I specify the length of it. So usually I just mention 20 because that's how long usually the numbers are or the digits are. And I mentioned 20 point here. And when I run proc print, it prints my observation in a birth date format. So it gives October 12, 1995. And one thing I want to mention, the digits or the numbers that are included in like 8 point, this includes each and every individual, syntax. So each and every individual code or number. So it includes the 1, includes the 0, it includes the forward slash. It's 1, 2, 3, 4, 5, 6, 7, 8, 8 digits long. So you have to make sure that you're counting even the forward slashes, whether there's a comma in between, you have to count those as a digit, as a length of your variable type. So now let's say we created our birth date as a word date, and we can see it's October 12, 1995. However, now we want to change this variable name, birth date, and we want to visualize it as birthday. So what I will do is I'll create another proc print. So this proc print I'm doing to visualize because I'm running procedures to visualize. I can also run these same steps, format, birth date, word date, in a data step if I wanted to actually have that data set saved. But since I'm just showing for visualization purpose, I'm showing it in a proc print procedure where it'll allow you to print the results and visualize that. So in the proc print statement, the label statement is used to create a label for your specified variable. So you have to mention the label statement in the proc print first statement after you've mentioned your data set. You end that, you specify your variable birth date, whichever one you're interested in. You don't always have to specify the variables. You can also just keep it without the variables and have all variables listed. But since I want to just see the birth date variable right now, I specified birth date. And then you run an option, a statement of label birth date. So you have label, the old variable is equal to the new variable in quotes. And then you specify the run option. So it's always the old variable is equal to the new variable, any changes that you're making. So here we created, to visualize, where we pretty much relabeled our variable name called birth date and called it birth date, since it was, that's easier for us to look at it. But this is only in our proc print procedure. So it didn't make any changes into our data set. Our data set still has birth date as the variable. So if you go back on proc print or let's say I don't want to run this label statement, I just add a star and end it with a semicolon. So this is a way to kind of write a note. You write a note with a star, your note here, and then you end it with a semicolon. After that, you can write the code. So data, and you see when you write the code, your data turns blue. Or if you write proc, your proc turns blue. So to write a note, it's start whatever note you have, and then you end it with a semicolon. And then that's when, you can start running on your syntax or your codes for any type of step that you're performing. It can be however long. So I can write anything in all this as long as I don't end it with a semicolon. Once I end it with a semicolon, if I want to rewrite another code, I have to make sure that I start it off with a star again. So that's one way to write your notes. So here, for example, I just put a star here because I don't want SAS to run this as a syntax in my proc print statement. And I'm gonna put a star here and a semicolon here so that, or I'm gonna exclude this label function and just run this proc print. And you see it's birth date. So originally my data set is still saved as birth date, but when I put the label statement and I put the label here in my proc print statement, I can visualize that variable as a birthday. It's just for, what's the easiest and what's best for you to visualize when you're looking at your SAS environment and you want to look at your data set. I don't want to look at the variable as birthday, or if I'm presenting it, I want to show it as birthday and then a different variable name rather than the complicated names that are already saved in the data sets. Okay, the next step is when we want to create new variables from existing variables. So as you know, we use a data step to make any amendments, any changes, any modifications in our data sets. So we can create or edit or add variables using our data step. To create variables, there's a few syntax that go into play. There are options such as either you just put the old variable name equal to the new variable name. And if you're creating like a numeric format, then you multiply it with the new variable name. So it's always the old variable equals to the new variable. That's something that's took me some time to understand, but always when we're running or creating variables, we always use the old variable equal to the new variable if we're performing any changes and making any modifications to our variables. Here, we're going to be using, for this example, we'll be using an if-else statement. So we're using an if-else statement to create a new variable from our existing variable. So if you look at my mylib heart data set, let's just look at status for now. Status is shown as dead and alive, right? There's two status. I want to make this into a binary coded variable. So I want to say that my status, if an individual status was alive, then we would call it 1. If an individual status was dead, then we would call it 0. So we want to create a new variable called status binary, which will give values called 1 for alive or 0 for dead. I'm recoding it to create a new variable. In this step will be performed using the data step. I'm creating a new variable called data mylib.myheart1. So mylib.myheart1 is a variable that myheart1 is a data set that I'm creating, which will be stored in my mylib library. I'm using my old data set, which is mylib.myheart. So I set it to my old data set. And these are the changes that will be made in my old data set to make my new data set called myheart1. So here I use the if-else statement because if we have either a character, a numeric variable, and we want to create it into a new variable, of course, we would have some values, So for example, if our status variable is alive, we want to create our new variable called status binary 1. So this is the if-else statement. So the first statement is saying that you start off with if your status is equal to alive. Alive is the text character that's in your variable status variable. So that's how it's shown. It's in a character format, so you have to put it in single quotes or quotations. And then you put the then option, then you create a new variable called status underscore binary equal to 1. So see here, in this option, I specified a single quote because it was a character variable, but I want to create a numeric variable. So I don't add any quotes. I just put in the number value, which is 1. Then I end the line with the semicolon. Now, the other option is else if. I follow it up with an else if. So any individual that did not have an alive as a status, else if status is equal to dead, then I will identify it, then create or the status binary variable will identify it as 0. So I called it else if. So if any individual had an alive option, then their status binary will show me as a 1. And if any individual had a status dead option, then the status binary individual will show me as a 0. I like to add another third layer, which is a status binary else last option, which is it's a disposal option, and I end it with else. So then else is pretty much anyone that was not identified as either alive or dead, I will put them into my my disposal status binary form, which is called my 99. So a negative 99. So pretty much I'm saying that if any individual did not from your status variable did not identify as alive or dead, then you will number them as negative 99. And then I'll show you when you look through your code and see whether it ran correctly, there's ways to see whether the statement was run correctly. And then I end the statement with semicolon and run. So let's just run this right now. Look at your log. If you look at your log here, you go on your log, you'll see there were 5,209 observations read from the data. The data set has 5,209 observations, 18 variables. So it went from 17 variables to 18 because we created a new variable called status binary. Okay, and then there's no red warning sign. So usually warning signs are red signs. You'll see it'll pop up in the log. And then no, error signs are red signs, and then the warning signs are yellow signs. So if like it's telling you that maybe there's like a syntax error or something, or like a code did not run because of some issue, it will come in yellow. Or if it doesn't identify the code, then it'll come in a red sign with an error. So the signs are helpful in telling whether our syntax or code is wrong or we need to make any changes to our code. So I created this mylib.myheart1 data set. And then if you scroll down here in your column section, you'll see status binary. Of course, I can see status binary if I scroll all the way down, and you'll see that your new variable is placed here, but I'll also show you another way of visualizing it. So I like to visualize it in the proc print just because it's cleaner and I don't have to scroll down, and I can also mention or see which variables that I changed and put them together. So I performed the proc print procedure. I only mentioned the variable status and status binary so that I can look at it next to each other and see whether it was done correctly or not. So I said alive was 1, dead is 0, right? And then another option, if your data set is long, you can't go through every row, is to run a proc frequency. So proc frequency, it pretty much is a way to look at whether the new variable that you've created fits or correctly fits with or like the code was performed correctly. So you run a frequency. It's a way to look at the frequency distribution, which when you're performing your descriptive statistics, this is one of the steps that you run to look at any categorical variable and obtain frequency distributions for them. So you perform proc frequency procedure called freq. Data is equal to mylib.myheart1, end it with a semicolon. Then I write tables. I'm creating a table, and I'm creating a table between my variable status times status underscore the star sign times status underscore binary. This is a 2x2 table that I'm creating. And then I put a / and I write list. List because I want each and every individual value to be listed and missing if there are any missing values. And then I end the statement with a missing option. Run. Now, when you run this, you see here that there were 3,218 individuals that were coded as alive, binary 1, and then 1,991 individuals that were coded as dead, binaries. The binary variable was coded as 0. And since there was no individual that was, missing or did not have a alive dead information, there was no -99, or else we would have had a -99. To see it in another way, I can also just look at my binary variable, which was my numeric variable, and run a proc means. So proc means allows me to look at the mean, median, mode of variables. So I'm going to run proc means data is equal to mylib.myheart1. Specify variable name status underscore binary. And run. And I can also specify and miss on the top option, which I'll show you I will be covering that in the next few portions. But nmiss gives us the number of missing missing rows that are in your status binary variable. So proc means allows us to obtain, the mean or the mode options, which will be covered in the next seminar series, but just if I just mention proc means variable status binary, here results. It tells me n, mean, standard deviation, minimum, maximum values. And if I want to know if any of them were missing, I mentioned the n miss instead. It will only give me whether there were any missing values in my binary coded variable. So since there were no missing values, we didn't have any negative 99 from our disposal bag. All right. Now, for example, we want to create a continuous variable instead of creating a status binary variable, we want to create a new variable called height multiplied, and we want to multiply our height by 2 times. So here we have now here's what changes. Here we want to create a new variable using our old variable. So we want, when we're making any like multiplications or additions or solving any formula based, we always start with the new variable first and then equal it to what the old variable that's being changed. So we'll be performing height multiplied. We'll create a new data set called myheart1, set it to your library, myheart1, mylib myheart1. So I'm just rewriting it over this data set. I'm not making a new data set. I'm rewriting it over this data set. And I'm creating a new variable called height underscore multiplied. I'm multiplying it to my previous height variable 2 times. When I run this statement, you see here, you have a new variable all the way on the bottom called height multiplied. If you scroll down here, you can see it's height multiplied here. And then if you want to look at it side by side, you can perform the proc print statement. In the results tab, you can see here, height multiplied is shown. So you have your original height variable and then the new variable that was created called height multiplied, and it's just a formula. So any formulas that are being made, or if you have any calculations to be performed using any pre-existing old variable, you can use that by performing the new statement equals to whatever formula or calculations you want to perform in terms of using the old variables. Okay. And then the next step is to check for missing data. So once that data management or data cleaning changes to your variables, additions, subtractions, formulas, all of that information has been performed once you've looked at your data set based off of your research question of interest. The next step is also to look for missing data. So, SAS has a separate way of looking at missing values for character and numeric data. For numeric values, it's usually shown as a period sign in your data set. And for character missing values, it's either just an empty single space in your data grid. So like, for example, this is numeric, it'll show it as a period sign. And like, look at the character, it'll be just either like an empty space, or there will be, something in there will be something with like a null string. So it'll probably be like a one null string option showing like this. So you can see here that the missing value, these will be considered as like missing values. And you can also specify certain values as missing. So sometimes people like to recode missing values to like a 0 or NA. So I would say if HCHD diag is equal to period sign, then HCHD diag is equal to NA. And I'll just give it as an NA option. But so I like to keep it as a period sign for numeric variables, because when we're running any analysis, when we perform any regression in ANOVA, it does not include those specific rows with missing values. It automatically uses complete cases. You can also use, the proc frequency or proc means option, as I showed earlier, to look at missing values. So for example, here, since there was none, it didn't list any missing. However, it would have like a missing value here. There's another option, which is like for continuous variables, you specify the nmiss option in your proc means procedure. When you're looking at the mean median mode, you specify nmiss. It lets you see for continuous variables how many variables are missing. And then let's run this. So I didn't specify any variable name, so it just gave me information on all And I don't know if you guys can see this, but it gave me information on all the variables that had any kind of missing observations. So for example, in AHCHD diagnosis variable, we had 3,760 missing values. In age at death, we had 3,218 missing values. Smoking had 36 missing values. So these are for the continuous variables. And now for the categorical, let's just say that we want to look at our categorical variable called death cause. We'll run a proc frequency on our and select tables and run and add include the variable death cause, put a / and you list it. So it'll list out all the categories or levels of your death cause variable, and then it'll show you missing value. Then you run the statement. So here, when you run the statement, you can see, okay, death cause had like cancer, had levels called cancer, cerebrovascular disease, coronary heart disease, other unknown. And then the frequency missing, there were 3,200 missing, 218 rows that had missing values for death cause. One other good benefit to know is that when I'm running a proc frequency and I want to run a table for multiple variables, I can always, after death cause, I can either include, let's say my mylib.myheart, let's just say that I want sex or col_status as my variable. So I'll add sex col_status with a space and then run this code again. It'll give me frequency distribution tables for each one of them. So it'll just separately create a frequency table for each individual variable, as long as there's a space in between. And then if I want to run any like 2x2 tables, then I have to create another tables row. And, let's say I want to create a 2x2 table called death cause with how many individuals had individual separate causes of death by sex. I did death cause times sex and then ended it with a semicolon, and I pressed the run statement. So there's two table statements. The first table statement asked for just the frequency distributions of each of these three variables. The second statement asked for a 2x2 table between cause of death and sex. And then here I can see that by sex, there were, 256 individuals that died due to cancer, 256 individuals, which is the frequency. And then 283 individuals that died, that were male, that died due to cancer. So this is a way of looking at like a 2x2 table, and I'll go more into detail in the next session for this. We can also use the CMIS function if we want to find rows that include complete cases. So sometimes we want to just work on complete cases in our data set and want to exclude rows that have missing values. What we can do, there's an option called using the CMIS statement, where you create a new data set called complete using my old data set, set to my old data set, mylib.myheart, and then we use the if option. So we said if CMIS, so if CMIS, the character variables, if any of the character variables, and I had to mention parentheses of all. So I'm pretty much saying that if any of the character variables in my data set were missing, equal to or like with the squiggly sign and then the equals to sign equals to 0, that means like it's either like missing, then we delete it. And then we used, and then we can use the nmiss option for all the numeric variables. So let's run this statement. Now, first we had 5,000 observations, and now we have 864. So you see how it pretty much, based on the character variables, if there were any character variables that were missing, it in a specific row, it deleted that row. So that's why our data set went from 5,000 rows to 864, because it means that any character variable that was shown as missing, it pretty much excluded that row. So sometimes, if there's not that much missing data and you don't want to, you want to perform a complete case analysis, you perform that complete case analysis by excluding those rows which have missing data. However, don't recommend it if it is a large data set because, I mean, I don't recommend it if there's a large number of missing data because, or, you know, it's on the basis of your research question, we have to see how we would handle missing data. There's various types of ways to handle missing data that I won't go into because this is an introductory course. But if you're working on, you know, like 100 observations and there's only 5 or 10 observations that have missing information, I can exclude that and consider a complete case analysis to perform for your analysis. And then you can run the proc print data complete to just visualize it to see whether there were all the character data had all information. So this is only for character. And if you specify and miss, then it would be for numeric variables. That's a way to handle or explore looking at your take account for your missing data. So before I end today, I want to lastly show you how to import an external data if it is not provided from my libraries in my SAS help folder. So if you go on the first navigation pane, you will click servers, files, and folders. You'll click your folder here, and like I said, you will select the upload files option and upload your externally located file, which is on your desktop, and upload that file into SAS. Now, I already uploaded the Heart CSV file into SAS, and so I will show you how that works in terms of importing this Heart CSV data to be able to be used in SAS Studio. One trick is that if it is a SAS 7b.dat file format file that's saved on your desktop, you don't have to import it as long as it has been uploaded into SAS Studio. However, if it's not saved in a SAS 7b.dat format and it's like an Excel, CSV, and it's in a different format, then you will have to import it into the SAS Studio environment once it has been uploaded. So the syntax for importing is important to understand. What I usually prefer to do is I double click here, Heart, double click that file, and then a new page on the right hand side pops up for me. And here, this is the syntax. This is an automatic importing syntax that's given to you once you double click any external file on that you've uploaded on SAS. So here's some file information. The file information is the Heart CSV data set that we're using from our seminar series folder that we've uploaded into. The output data is important to understand because currently the output data set name is called import, and the library that it is being saved into is the work library. However, because we want to use it many times, we will be changing this output data information for us. So I'm going to pull this up a little bit, and here you can see the code. So the first 4 lines are just, notes for the codes that's always provided every time you double click an external file that has been uploaded into SAS to import. The web drop table is, it's pretty much the web drop table, this option, which is given to you, it's pretty much saying that if there was a data set called import in your work library, and let's go on work library here. If there was a data set called import in our works library that was already saved or being used in this session, then it will drop that data table and it will remove it. And then it will it will import it with this code, this file name to run code, and call it work import. So if there was a previous file that I had saved as work.import in my work library, then this work drop table option would drop that table or remove that table from my work library or data table. And then it will create an import based on these specific steps and create a new work.import table. So here, and I'll go back because I don't want to use this, but here there's a few options to recognize, but I'll go back here because that's more important. So here we have few options, which is the file name statement. The file name statement pretty much specifies the path where we can select our data from. So the file name statement, it pretty much will tell us to look at the path where our data was selected from, and the path was seminar series. So if you just go on Heart, right click and select properties, you can get the path for your data set. and you'll specify that. The refill option is it assigns a nickname where your data set is located. So it's assigning a nickname called refill to our data set, to where our data set is located, and it's using our file heart. So it assigned a nickname refill to our heart data set from that seminar series path. And then the next step is to run the proc import option, which is pretty much triggers the input step. The next step is the proc import option. It's saying use my proc import, perform my import action, trigger the import behavior, and select my nicknamed refill file and import that file. Now DBMS is it gives us the option to tell SAS what engine to use to read the data in. So since our, since our external file was saved in a CSV format, we will specify the DBMS is equal to CSV. If it was in an XLSX format, we will specify DBMS is equal to XLSX. So based off of what the data file was uploaded as, you will have to change your DBMS on the basis of that, so it can easily and accurately identify your data set. And then the out option tells SAS where you want to put the data set into. So I want to put my data set, which was nicknamed refill, my heart data set that had been nicknamed refill, I want to put it into my library and call it example heart instead. So I will put that out option as mylib.example heart. So what I'm pretty much saying is, take my data set called heart that I gave a nickname to, called refill. I want to put it into I want to save it completely into my mylib library. But I want to call it, instead of refill, I want to call it example heart. I can also keep refill as an option, but instead I want to call it example heart. So I will use, I will say out is equal to mylib.example heart, put a semicolon, and then the get names option is pretty much saying that my first row is variables. So I want to mention that identify the first row as variable names rather than identifying it as an observation. And then I select this run statement. I select all these from line 430 to 436, run it. And then you can see here, my libraries, go on my libraries work. No, sorry, my lib example heart data set was created. So this same data set was created called example heart. And then you can just run your proc contents to visualize whether the data set was created. So this is a session for today. We imported the data set. We learned some basic syntax for SAS coding. The next session will be on April 25th. And I will be sharing more information on performing data analysis. So running, means, descriptive statistics, some data visualizations, and perform some basic statistical analysis such as t-tests and one-way ANOVAs, or, chi-square tests in the next steps. If you have any additional questions, please feel free to reach out to me. We have, the next session is held on April 25th. And I can send over an email to you with our website information, but you can also access going on Bouvet Research Administration page. You'll see in the Teams option, there will be Research Biostatistics Center. Let me just see if I can show that to you right now instead for anyone who's on. Save this for now. Yeah, Biostatistics Research, we have Zoom virtual office hours every Monday and Wednesday, 1 to 2 p.m. Feel free to register for the virtual office hours for 10 to 15 minutes if you have any quick questions, for professors or PI faculty who are working on grant-based projects, feel free to request a consultation through the NU community. I also take external requests from the request consultation here for non-Northeastern members. And then we have resources here where training and webinar videos. So I have information on the power analysis that I had hosted earlier this year, and then the next recordings will be coming up by the end of this month. So hopefully, I'll have the recordings included on the training and webinar videos for your resources, but feel free to email me if you have any additional questions or if you want any more information on any resources. We do have a SharePoint page that's accessible for Northeastern University members. So there are some resources for students who would like to, learn on their own time, and I can provide some guidance on what kind of statistical tests to perform. There's some links to some resources that can be beneficial to you. Sorry, let me just stop sharing for 1 second. Copy for the SAS code, would you like? Marie? I'm assuming yes. Yeah, sure. I can share the copy. I'd recommend emailing. I can email that to you directly. If anyone wants a copy of the code shared to me, please, feel free to email me on n.singh@northeastern.edu. I can send the SAS code copy to you that I've created, and then, you can walk it through on your own time, if that helps. But thank you for joining today, and I hope, if you want to learn any data analysis, basic statistical analysis portions, feel free to join on April 25th. It's the same time, 12 to 1:30, and I hope that this was helpful, and I'll be hosting more sessions with, different softwares, our studio. So yeah, thank you. Have a great day.